Good morning, everybody. How are you all? Today we are going to talk about a problem on multiple regression. So I'll share my computer screen with you. So if I move this a little bit down, here is a multiple regression model between violent crime rates, crime crimes per 100,000 population, which is Y, versus police officer wages in mean dollar police officer wages are in dollars per hour, mean dollars per hour, which is X1, and graduation rate percent, which is X2. Dependent variable is violent crime rate. S, standard deviation of the error, is 156.9 with 47 degrees of freedom. So the first table gives you the source, sum of the sources, degrees of freedom, mean square, and F ratio. And the second table gives you the variable, the corresponding coefficient, standard error of the coefficient, t ratio, and the corresponding p value. So remember, you have intercept as the first variable. The next variable is police officer wage in dollars per hour, mean dollars per hour, and the graduation rate. So each of them associated with a coefficient, standard error, t ratio, and the p value. The first part is write the regression model. What part B? What does the coefficient of police officer wage? What does the police officer wage mean in context of the regression model? Part C, in a state in which the average police officer wage is $20 per hour and the high school graduation rate is 70%, what does the model estimate the violent crime rate would be? Part D, is this likely to be a good prediction? What do you think? Part E is do a F test on the model. So I will create some space by reducing this, and I will move this up a little bit. Okay. So my solution, first part A, is the regression model. So that is predicted violent crime per 100,000 population. Because it is predicted, I put a hat on top of it. Is equal to, from the second table, the intercept is 1370.22 plus the coefficient for police officer wage is 0.7947 times police officer wage. Okay, let's make sure. Yeah, I made a mistake, so I'll first correct it. This is the coefficient for graduation rate is minus. Okay, this is minus. Okay, so if I go back here, then we are continuing with the model because the coefficient of the graduation rate is negative. It is minus 12.641 graduation rate. So this is the multiple regression model. Violent crime, predicted value of violent crime is given by this equation 1370.22, which is the constant term, plus 0.7947 times the police officer wage per hour, average wage per hour, minus 12.641 times graduation rating percent. Okay. So part B asks for what does the coefficient of police officer wage mean in the context of multiple regression. Okay, the regression model. Okay. So we can write part B. Among states with similar graduation rate, that is, we hold the graduation rate constant. Graduation rates. Graduation rates. States with higher police officer wages. Higher police officer wages have more crime at the rate of 0.7947 crimes per 100,000. For each dollar per hour of wage average. Per hour of average wage. Per hour. For each dollar. So let me erase this correctly and write correctly so that there is no confusion. Police officer. Officer. Um, uh, Let me get this also. Write it. Police for each dollar per hour of wages. That means if we hold the graduation rate constant for every dollar increase in police officer wages, the crime rate per 1,000, per 100,000, will go up by 0.7947. Okay. Now let's create some space and do part C. Okay. So part C. In a state in which the police officer wage is $20 per hour and the high school graduation is 70%, what does this model estimate the crime rate to be? So crime rate, violent crime. So predicted violent crime will be equal to 1370.22 plus 0.7947 times police officer wage is 20 minus 12.641 times individual graduation rate is 70. So we will use the calculator to do this. So 1370.1370.22 plus 0.7947 times 20 minus 12.641 times 70. And the answer is 501.244. So that is 501.24. So the estimate of the violent crime per 100,000 is 501.24. Okay. Then we will create some space and do part D. So part D says, is this likely to be a good prediction? What do you think? Okay. I think the estimate is not a good prediction. Not a good prediction. Because R square, a coefficient of determination, is only 22.4%. Okay. And if we go up, we can see that the R square is given as 22.4% right over here, 22.4%. Okay. Now to do the F test, okay, we need the degrees of freedom for regression, which is 2, and degrees of freedom for the residual, which is 47. Okay. So that is part E. So part E, do a F test. Okay. Now, degrees of freedom of regression is equal to 2, and degrees of freedom of residual is given as 47. Okay. And F statistic, the test statistic is equal to, I have to again move up to find out what is the test statistic for F, is 6.786. Is 6. Sorry, I'll create some more space. So 6.786. Okay. So we need to find the p-value or probability of getting a test statistic, as extreme as 6.786. Okay. Okay. So let me draw the F curve for you. So this is probability on the vertical axis and F values on the horizontal axis. And the F curve looks like this. Oops, we erase it and draw it nicely. So not like this. Let me erase all of this and then draw the F curve nicely. Okay, so go back here. Okay, so we have probability on the vertical axis, like I said, and F on the horizontal axis, and the F curve looks like this. Okay. And our test statistic is F is 6.786 on the horizontal axis. And P value is the area. This is your P value, which is area to the right of 6.786. Also, one thing to note is this curve stretches all the way to 1E99, means a large number on the right side. This is 1E99 means infinity on the right. E stands for exponent, 1 followed by 99 zeros. So we will find the p-value, which is area to the right of the curve, right of actually 6.786, stretching from 6.786 to infinity on the right. And we need to the 2 degrees of freedom. One is for the regression, 2 residual is 47. So let me create some space. Okay. First write what is the F test all about. F test. Okay. Null hypothesis is beta 1 equal to beta 2 is equal to 0. Slope in the population equal to 0. Okay, equal to 0. And that's your H sub 0. So null hypothesis. Your alternate is at least one of the betas, betas is different from 0, is different from 0. Okay. Our alpha value is 0.05. We will find the p-value to, we have to use the calculator to find the value. So use TI-84, TI-84. So let me write this correctly. Use TI-84 to find the p-value. Or probability of probability of getting a test statistic as extreme as in this case 6.786. That is area under the F curve, under the F curve to the right of 6.786. Okay. Okay. The 2 degrees of freedom associated with this F curve are degrees of freedom in the numerator, degrees of freedom in the numerator, which is equal to degrees of freedom for regression, of freedom for regression, for regression. So dfn is equal to 2. Okay, and if I create some more space, okay, and so first is the degrees of freedom of the numerator. So this is number 1. Number 2 is degrees of freedom in the denominator, which is degrees of freedom in the denominator. That means equal to degrees of freedom of the residual of, so degrees of freedom in the denominator, degrees of freedom of the residual. And in this problem, degrees of freedom of the denominator is 47. So these are the two things we have to use. Degrees of freedom in the numerator is 2 and degrees of denominator freedom is 47. Okay. So as I told you, we will be using the calculator. So, okay. So first we will press second verse. Then we scroll down to FCDF. So second verse, scroll down to FCDF, not PDF, CDF. Why C? Because we are finding the area to the right of 6.786. Okay, cumulative area. Okay, C stands for cumulative. So by lower is where I'm starting from, 6.786. Okay, so my lower is the F value, the test statistic, which is 6.786. Okay, my upper is a very large value on the right hand side. The curve extends to infinity. So first I type 1, then I press the second button, then I press the comma button, which is on top of 7 button. So 1, then second button, then comma button on top of 7, which gives E, and then 99. So we will get, when we press second button and then comma button, it gives the capital E and then type 99. This means 1 followed by 99 zeros. Okay. Now it asks for degrees of freedom in the numerator, which is equal to degrees of freedom in your regression model, which is 2. So type in 2. And then degrees of freedom in the denominator, which is the residual degrees of freedom, is 47. Type in 47. Then go down to paste and hit enter and enter. Whenever you are on paste, you have to hit enter twice. Enter and enter. Enter and enter. And the p-value, I'll write it over here. P-value comes out equal to 0.0026, you might say. Compare that with alpha equal to 0.05. P is less than alpha. Decision reject 80. The conclusion is at alpha equal to 0.05, there is enough evidence to support HA, which states at least one of the betas is not zero. Betas is not zero. Okay. So I will stop here today. If you have any question or comment, please write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I appreciate that. If you like this video, please share it with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll see you next time with another interesting problem, interesting solution. Take care. Have a nice day. See you next time.